Hello, everyone. In this video, I'll be going through what's new in Perception 8.70. My name is Krista Tweed. I'm an applications engineer with HBK, and I'm based in Madison, Wisconsin in the US. So we'll walk through the new features in this release of software. We've added some bigger features in our ePower suite that's used when you use GenDAC and Perception as a power analyzer, some general usability improvements, of course, some bug fixes, and some new hardware that's also part of this release. Measurement uncertainty calculation for set points. So when you're using our eDrive power analyzer and you're going to do an efficiency map, you're running your system through a set of set points, torque and speed set points, and taking a snapshot of data at each point. Many of our users are very interested to understand what the uncertainty of that measurement is, both at the efficiency and the power level. And it's a very involved process to make that calculation, especially given that throughout an efficiency map, you're taking data at a wide variety of set points. So your currents are changing, your voltages are changing, torque and speed are adapting, which means measurement uncertainty has to be calculated for each individual set point. And there are often thousands of them in a given efficiency map. What we've done in previous releases of Perception, there was a measurement uncertainty sheet where you could enter all of the values for a particular set point and determine what the measurement uncertainty is. We've taken it a step farther with Perception version 8.70, and now in the optional analysis settings dialog within ePower, you can actually tell Perception, click a checkbox, yes, I want to know the measurement uncertainty for each of these components in my test, the power source, the inverter, the motor, all of the above. When you do that, Perception's going to give you a yellow exclamation point if it doesn't have all the information it needs to be able to calculate the measurement uncertainty. In this case, we were missing the ambient temperature, so you enter that, that's the temperature of the mainframe. Once everything is green checkbox, then you're going to have some new data sources. So in your set point table, there will be two more values that you can add to see in that set point table, and they're automatically included in the set point table that's created as you take data for both the absolute and the relative measurement uncertainty at each set point. A few details down here in italics at the bottom of the slide. You do need to have your cycle detect for the master set to 1 cycle. It's no problem to go ahead and do additional averaging, but in the component itself in ePower, you've got to have that cycle detect set to quantity 1. And this measurement uncertainty is only calculated live, so there's no post-process formula to do it. And this measurement uncertainty calculation is done on the Perception side, not in the hardware, which means it's not available to stream out to the field bus. But it is available for you to view in Perception, and it is included with that set point file with all of the other cycle-based calculations that are added to that set point file automatically. You can also display that into its own efficiency map. So here what you can see is the set point table at the top of this display, the efficiency map that's been available in earlier versions of Perception. So you've got torque on the Y, speed on the X, and efficiency on the Z. And then also they put the relative efficiency as a percentage on the Z-axis in this second efficiency map. So they have an idea of what that uncertainty is immediately as soon as they see the efficiency map itself. There is an extensive quick start guide for this that's for the set point creation, and that's available in the help folder of Perception after you've installed version 8.70. Second topic, torque ripple analysis. I'm sure most of you know torque ripple is just an unwanted effect of each electric drive that can be driven by the control method, the mechanical designs, and in general, it adds unwanted results like noise, vibration, and a decreased lifetime for the motor. So we have many users who have been looking at torque ripple with perception for many years. This is something we've been able to do for a long time. What we've changed with this release is we've automated the setup of that calculation. You don't have to set it all up manually anymore. So a new in the optional analysis setup dialog for torque ripple, you select that for the motor, and Perception's going to automatically create formulas for that torque ripple. So you've got your capital M is torque over your cycle master, typically the electrical cycle. So that's used for efficiency calculation purposes. We're automatically adding formulas to calculate the max and the min and the absolute value of the ripple and the percentage value of the ripple. So you'll see those additional data sources available in the data sources navigator. And you can also show them both as a waveform or as a number in a meter. In this case, these additional formulas are available post-process as well. So if you tell Perception that you would like to create post-process formulas that mimic your real-time formulas, these formulas will be added to those post formulas. And of course, you could also do a mapping with that ripple percentage as well. So in this case, we can see the efficiency map on the left. The map on the right is showing the ripple percentage for the torque ripple. So you can see that just because the drive might operate efficiently doesn't necessarily mean that everything else about the system is operating well. Your torque ripple might be high, which means that may still be an operating point you want to avoid. User-defined variables in the ePower suite. Since ePower was begun, we've always used predefined variable names following international naming conventions. But we had some customers tell us they have their own company standards as far as how they like to name things. So now in the ePower suite menu, you have to be in the ePower suite sheet, and then that menu is available. Select user-defined naming, and a new dialog will open, and you can change those variable names. So here, instead of M for torque, we write out torque. Instead of M instantaneous, we say torque fast. Instead of N for speed, we write out speed and say speed fast. So now when I look in the data sources navigator, I see those new data source names for those variables. And of course, in all of the objects in Perception, both in the ePower suite and the meters and the waveform displays, those new names are used as well. And one final new automatic additional calculations. In electric drives, it's often of interest to understand how much of the active power is in the fundamental and how much is in the other harmonics. And the reason for that is that the active power in the fundamental is the useful power, and the harmonic power typically leads to unwanted effects and losses. And the same is true for the harmonic RMS current. So we have another new column called Harmonic Power and RMS that will automatically create functions to find those values. So what does that look like? We're going to create, it's more than just the formulas shown here. These are just for the fundamental harmonic, but we're going to generate automatically all of the formulas that are needed. And then in your data sources, you're going to see a new group called harmonics, and that's going to have the harmonic and the fundamental active power, RMS of voltage and current, and that in the harmonics as well for each individual phase and for all three phases combined together. And note that there is a column already called the fundamental of RMS. So those formulas have already existed for several releases. And so those formulas will be in a slightly different portion of the real-time formula database. What we're adding now is the additional formulas. for the harmonic power as well. And what does that look like? Those formulas give us waveforms and values that we can look at and understand what's going on. What you're seeing in this plot here, the active power, P, you can see is consistent across this entire plot. So overall, our active power isn't changing, but what we're also viewing is the switching frequency for the motor, and then the total harmonic RMS of current and the total harmonic power. And what you can see is that as the switching frequency increases, those harmonic values are decreasing. So even though the active power is staying the same, the overall active power, less and less of that is coming from the harmonics, which means there's more available for useful power. Every perception release has some general usability improvements, just always trying to optimize the user interface and make it consistent across all of the different objects in perception. And so you can see here with these different types of objects, we've got the set point map, the scope, the meter. We've just made it more consistent as far as what options are available from the hamburger menu in the left, and keeping that wording consistent. Just should make it more intuitive to use the software. And I also want to point out, in case people haven't noticed it, in an earlier release, this expansion icon here was added, and I think this is really useful. If you have a sheet of perception that has 4 different objects in that single sheet, and you're interested in just expanding one of those objects to temporarily see it more clearly, you can click that expansion box. That's going to maximize it and fill up the whole sheet with just that one object. And then the icon changes and you can minimize it again as well. And I think that's pretty useful. eDrive generic settings. Over time, we'd added a lot more features into the generic settings, and so that dialog had gotten really long, and it was kind of confusing to look at it and find what you were looking for. So they restructured that dialog into 4 separate tabs, groups of the user interface behaviors, setup parameters, averaging, and mean and standard deviation, so that it's easier to find what you're looking for and be able to make those adjustments. You are also going to see in perception some new question marks showing up. These are context help, what we call context help. So if you click that question mark, it's going to open a PDF file that describes that feature that's by the question mark. We know that some of the newer features in perception are not as well documented as we would like, and this context help puts that right at your fingertips. So as you're looking and you're, set point of meter averaging, what exactly does that mean? Then you can click that context help, the dialog opens, and you can learn more about the options available in that list. All right, some other general improvements. The set point map has been updated to give you more flexibility to adapt the map's appearance and make it look the way that you want to. So you've got more flexibility on scaling those and setting the color changes. A big change is that the default setting for the raw torque measuring time has been adjusted. In the past, it was always set to 50 milliseconds by default. And for many of the electric drives out on the market today, that's simply too long. And once you've recorded the data, you can't go back and change it. Now, what is that measuring time? We recommend measuring torque and speed as digital signals. And that measuring time is the amount of time the timer counter channel watches that digital pulse train coming to the power analyzer, and then determines the frequency, in the case of torque, determines the frequency of that pulse train and converts that frequency into the torque value. What we've done is adjust that default to 1 microsecond, which gives you the maximum dynamic behavior for our MRAW signal. And you can then go in and adjust that default up to as high as 200 microseconds. I will point out there is a YouTube video that describes how torque and speed measurements are made and all the different torque and speed parameters that are available in perception on our YouTube video. And these slides will be available for you to download along with this video so that you can access that link and find those details. So now the new settings are that the MRAW can be set between 1 microsecond and 200 microseconds. M instantaneous defaults to 1 millisecond, which is what it always was before. And then M is just torque, and that's a cycle master that you set in the component in ePower. It's typically the inverter cycle detect, but it might also be set to 1 rotation of the motor. It's your choice. Improved asynchronous signal export. In the past, when you export data out of perception, there are generally 2 types of data you're exporting out of perception. One is synchronous, what we call synchronous, and that's your analog data that you're recording at your, whatever your selected sample rate is, 500 kilosamples a second, 1 megasample. And then we have asynchronous data, and that's your cycle-based calculations. So those calculations have 1 result per cycle. And so in general, there's just not nearly as many data points. But in the past, if you were going to export data out, you had to choose a single sample rate to export everything. Both the asynchronous and the synchronous results all were at the same sample rate. And that made the export files very big, especially if you were going to Excel or ASCII or some kind of format like that. You now have the possibility to export the asynchronous result as a custom rate or actually export them as whatever their async value was. So this was implemented in 8.60 perception for the MDF4 and MATLAB export formats. And now ASCII and Excel have been expanded to support that as well. Export channel selection. The 8.60 release added this capability to the general export dialog, but it was not available when you did a batch processing. So if you wanted to export data, say 5 or 10 or multiple data files all at the same time and have perception automation take care of that for you, you didn't have that capability. But now in recordings batch processing, you select export to ASCII, configure it. You now have the option for a custom channel selection where you can make the selections for exactly the channels that you want included in that export rather than having to put all those channels into a specific page or pane, etc. Improved calculations for set point averaging. We have some users that it's really important for them to be able to either look at their field bus data and their set point file or their raw data and their set point file when doing an efficiency map and make those things match up. And before version 8.70, when a set point trigger came in, what we put into the set point value was not the first sample that was available, but the second. And that made those things not match up perfectly. So we had a slight delay between set point values, calculations, and the trigger. It is now possible to start calculating with the next value after the trigger. And you actually have 4 different options for those calculations. There is a context help. And so I highly recommend looking at that document if it's important for you to make the selection as to whether you want that averaging to take place on the mainframe within the real-time formula database or on the perception side, and that will determine how things all line up. Post-processing of cycle-based sweeps. So perception has 2 different formula databases. The real-time formula database is the one that is calculations are done in the hardware itself, so that all happens in real time. Sometimes there's a need to go back and reprocess raw data post-process in our formula database, FDB, or post-process formula database. And the way that the cycle detect was handled in the formula database was different than in the real-time formula database. And that caused some confusion for some users. So what we've done now is if you make the selection to create post-process formulas from the real-time formulas, we're going to automatically set up formulas that use the cycle master signal from the real-time formula database when doing those post-process calculations. That will make things line up with what those real-time results are. You can always go into this formula database and change this inverter cycle, use RTFB to 0. That tells it, don't do that. I'm going to calculate my own cycle master in the post-process formula database. Improved cycle-based recording. So we had an option, we do still have an option in the control panel of the ePower suite that you can check the box to start and stop trigger on cycles. And that means every trigger that's recorded, you want it to be a specific number of cycles long, that sweep length, rather than being time-based. And when you did that automatically in perception, several things happened in the background and it wasn't always clear what was going on. So we've synchronized or lined up some of that, a little improved that. So now when you checkbox the start and stop trigger on cycles, you're going to see in the generic settings dialog, the averaging method will automatically change to number of cycles, and that duration will match what you've entered in the control panel. And in the acquisition page of the settings sheet, you're also going to see the pre-trigger and post-trigger duration automatically set to 0 because we're basing that on a number of cycles, not on a time. There will be additional improvements to this going forward, but this was a first step. We had a request from users to be able to modify the cycle detect parameters from the field buses. So those commands have been added. That's now in the generic settings dialog in ePower. You can go to setup parameters and check the box for set cycle detect parameters from field buses, set that start index, and you can click that question mark to see a complete document that describes how those commands work. All right, when you chose the option for number of cycles as a sweep length, that automatically turned on a trigger arm feature in perception. Before this release, that trigger arm could only come in through the field bus or through a TTL signal, but there wasn't a way to do it manually in perception. So there was no way to manually do a set point map using that arm signal without having automation set up. What we've done is now added the functionality to perception so that you can do that manually if you wish. So if you have the use trigger arm selected in the acquisition page of perception, what you're going to see in the control panel dialog, instead of a trigger, you're going to see an arm button. So you start your recording, and now perception will tell you I'm waiting for arm. In this case, I've got the system set up to take 5 triggers and stop. So it's saying I'm waiting for arm 1 of 5. I click the arm button, and now it's ready to be triggered. So I can trigger it. It will record that triggered sweep. And then it will go back to telling me, now I'm waiting for arm number 2. So each trigger will need its own individual arm, and you can manually have that arming done through the control panel in ePower. We've also improved how we change spans via field bus remote control. So people are often, as they're doing a set point map, the current levels often change significantly, and so they need to increase the span of the current channels to accept the higher current values as they go up in speed. In the past, this was always done one channel at a time, and it just added a lot of time to the process. So what they did was change it to where now they're doing the 3 channels in parallel, and they've greatly decreased the time that it takes to make that span change from somewhere between 2 and 4 seconds to 500 to 700 milliseconds. So really been able to significantly decrease that test time. And this shows you the same thing, but graphically. At the top is how the process used to take place. Change channel 1, then channel 2, then channel 3. And now all 3 channels are going to happen in parallel. And so that's overall going to save you time at each set point where that change is required. For users that needed to renumber the CAN and EtherCAT message IDs, say after the automatic naming had already taken place, they needed to adjust some of those. You used to have to do those one at a time. Now you can select a group of those channels just using Shift-Click in the publishing page, change the first one, and it will automatically adjust those numbers for the rest of the columns in sequence. So that makes that process much faster. If you're interested in upgrading to version 8.70, the maintenance on your Perception license must be good through August 1st, 2024. So if you need to look at where that is, if in Perception you go to your help menu and select about Perception, you're going to see your Perception license serial number and the maintenance expiration date. The installation file for version 8.70 is available on the Perception downloads page of our website. You'll see it, an entry like this. Just click that Perception software 64-bit. You can also see a link to download the release notes and see all the nitty-gritty details of what's in this software release. And then the final topic today, I'm not going to go into too much detail, but I do want to let you know about some new hardware that is available for eDrive, which we call our remote probes. Before the remote probes, this was your typical setup in a test cell. So you've got your device under test on the left, you've got voltage coming back to the mainframe, to the power module. You've got your CTs connecting to the power supply interface unit, and those go back to the mainframe. Your torque and speed signals all go back to the mainframe, and whatever other signals you have. In general, that cabling can be pretty challenging. You've got to be very careful about how you're running those high voltage cables because you do have high voltage coming both into the inverter and into the machine and running back to the power analyzer. And so you've got to be careful about the safety side of that. But in general, you can also have EMC issues. That voltage is not only high voltage, but it's got high switching frequencies. And so when those voltage cables are crossing the current cables or just even running next to them closely, you're going to have EMC challenges. What the remote probes give you the ability to do is to move that measurement point much closer to your device under test. So the remote probe, remote voltage probe, remote current probe are going to sit close to your device under test, and a single fiber optic cable then runs back to the eDrive mainframe, where what we call a receiver card sits in the mainframe to accept that fiber optic cable. So the remote voltage probe has 4 voltage channels. You can easily take care of a power source plus a 3-phase inverter, and your current is the same. And because this fiber optic link is digital, then you don't have that high voltage traveling over those big distances. You've minimized your EMC issues. Shorter cable length is always good. Also, the calibration of these channels is all in the remote probe itself. So when it comes time to calibrate the system, you can send in just the remote probe to do that calibration. You don't have to remove the entire mainframe. And the current remote probe has 2 different versions. One has an integrated CT power supply so that you've basically removed the one box and all of those connections from your system. And these fiber optic cables can be up to 100 meters long. So the first variants are a 4-channel voltage remote probe. The channels on that accept up to plus minus 2000 volts DC, and have support up to a 2 megasample per second sample rate. On the current probe side, you've got the built-in burden resistors, just like we had with our power modules previously. So you've got 6 different current ranges up to plus or minus 2 amps, built-in burden resistors, and you can use either voltage input or current input. So you can use current clamps or CTs, same as before, and that same 2 megasample per second sample rate. The receiver card looks like this. So that's what sits in your mainframe. And today with this initial release, it can support 2 probes, 1 voltage, 1 current. And it has the DSP on board to support all the same real-time calculations that are available in our other power modules. There is more information available on the Remote Probes website page if you would like to learn more. As I said, I am going to work and we'll get the slides available so that you can look at the description of this video on YouTube and hopefully download that. If you have technical questions and you're in the Americas, you can contact support at usa.hbm.com. If you're in Europe or Asia, it's support at hbkworld.com. Thank you very much for your attention, and we hope to hear from you soon.